When I was a kid, I used to play a game called Reversi, or I think in some countries they call it Othello. And the concept is it's two players, and each player has a set of chips. And in both cases, the chips are white on one side and black on the other. And the objective was to capture your opponent's chips by surrounding them. Now, in trying to think of ways to explain elastic block storage, this game came to mind. So bear with me here. So elastic block storage, or EBS, just think virtual hard drives. They can only be used with EC2, and they're tied to a single AZ. Now this is really important because they don't inherently provide multi-AZ redundancy for your data. And I can tell you many times I've created a volume in an AZ, not paying attention. Then I go to try to attach it to my EC2 instance and it can't be found, and it takes me a few seconds to figure out, oh yeah, I created it in the wrong AZ. So that's something to keep in mind. There's a variety of optimized choices for IOPS, throughput, and cost, and you'll remember from our concepts front of this chapter, there is a difference between IOPS and throughput. And snapshots are absolutely great, and we're going to talk in depth about how snapshots work. So again, using my Othello or Reversi example, an elastic block storage, just think about it as a big field of play. And in this case, we're going to pay for all 64 blocks, even though we may only be using 4 blocks at the time. Now let's write some data. And so we've committed some data, we've written some data to our block storage, and we're still paying for 64 blocks, but now we have less space available. Let's compare and contrast EBS versus instance stores. Now, instance stores, the most important thing to remember about them is think of them as temporary. They are only available when the EC2 instance is running. When you stop it or terminate it, that data goes away. And instance stores are locked to that EC2 instance. Now, EBS volumes, on the other hand, are not locked. You can attach them and detach them and attach them to other EC2 instances. You can also create snapshots. Now, why would I want to use an instance store if the data is just temporary? Well, you have better performance because the instance store is really, you can think of that as direct attached storage, whereas EBS rides over the network. It still looks like a volume and feels like a volume, but you're going to suffer a little bit of performance because the EC2 instance is going over the network to access that volume. EBS snapshots are one of the most useful tools in the whole AWS landscape. For starters, they're a really cost-effective and easy backup strategy. A lot of times I'll set up a CloudWatch job to take a periodic snapshot of my volumes, and that's my backup strategy because if I have to restore, I just find the point in time where I need to restore and recreate that volume. They're also useful for sharing sets of data with others. Let's say I'm a scientist and I'm doing some research and I have a drive full of several gigabytes of data, and I want to share with another colleague at another university. So I can take a snapshot of that EBS volume, and then I can share that snapshot with that other person's account, and then they can create a volume based off that snapshot and have access to the same data that I have. I can also use snapshots to migrate EC2 instances to a new AZ or a new region. As I said earlier, sometimes I'll accidentally create a volume in the wrong AZ. Well, if I didn't want to lose the data on that volume, I could create a snapshot and then recreate that volume in the new AZ or the new region exactly as it was when I took the snapshot. Snapshots are also handy if you want to convert an unencrypted volume to an encrypted volume. All you have to do is take a snapshot of your unencrypted volume, and then when you go to create a new volume, check the little checkbox that says encryption. And then your new volume will be encrypted, and then you can mount that on your EC2 instance. Let's take a look at how snapshots work using the Othello example. So for starters here, we have a 64 block field. We're only using 4 blocks. Our first initial snapshot is going to contain the whole thing. Now we've added some data. We've added two chips here. And snapshot number 2 is only going to include those 2 additional chips that we've added. And if we add another chip, and let's say we delete a chip, Snapshot number 3 is going to take care of recording that deletion as well as recording the information for the newly added item. Now, this is important because snapshot number 1 may occupy 64 blocks of storage on S3, and that's what you're getting charged for. But snapshot number 2 and snapshot number 3 occupy only the small fraction of data that is changed. So that's why it comes in handy and very cost effective, is because you can do very frequent snapshots, but each snapshot doesn't equate to the full size of your original EBS volume. Now let's say we wanted to restore to snapshot number 2. So what AWS does is take snapshot number 1, it adds on the changes that we did with snapshot number 2 and creates the volume from that. Now here's a question I get asked all the time. So if we delete snapshot number 2, do we lose the ability to restore snap 3? No, we do not. AWS does some magic on the back to ensure that we can absolutely recreate volumes from snap 1 or snap 3. But since snap 2 is deleted, we can't recreate that volume for the point in time representing snap 2. So what happens if we delete our original snapshot number 1? Are we going to lose our ability to restore the later snapshots? Nope, not at all. So think about snapshots as nothing more than a collection of pointers to data which is stored in S3. And through AWS magic, those pointers are automatically pulled forward and incorporated into the next most recent snap. So we can restore snap 2 perfectly fine and subsequent snaps as well.